Hello and welcome to this episode of Math with Martinez. We are looking at a continuation of our first lesson here in our unit on trigonometric functions. We are representing angles in both radian and degrees based on rotation in our coordinate plane. So we've already looked at how to represent both positive and negative angle rotations, and that is going to lead into this idea of coterminal angles. Angles that are in standard position with the same terminal side are called coterminal angles. That's the big definition. If they have the same terminal side, then they are coterminal angles. So let's determine whether the two angles here are coterminal. We'll look at this little diagram over in the side margin, and I just want to draw your attention to what happens here with these two values. See, what we have is 90 and negative 270. They are coterminal because they both have a terminal side right here. What's fascinating about these two values is if you take the positive angle value and then subtract the negative rotation value, what do you know about the result of that? What does that give you? 90 minus a negative 270 is 360 degrees. So if you are working with two angles, one positive rotation, one negative, the difference of them should give you a full rotation. The difference of the positive and the negative angles should be 360 degrees, or if you're working in radians, 2 pi. Or some multiple of that. It should be a full rotation that you have at the end. So think about what we've got here. We've got two angles. We've got our positive angle, which is 305 degrees of rotation. And what happens when we subtract from that the negative angle, that negative 55 degrees? What is the sum, or the difference, I should say, of those? I say sum because minus a negative is addition. So when you take 305 and you say minus that negative 55, that is 360 degrees. So are they? Yes. They are, because their difference is 360. What about, for example, 20 here? Would 30 and negative 170, are those examples of coterminal angles? Can you guys try that one? Well, you would be taking 30 degrees and subtracting from that a negative 170. And the result of that is not going to give you 360. It's only 200 degrees. So this is a solid no, not coterminal. They do not end in the same location. Okay, well, what about 21? Now we're working with values that are in radian measure. Well, we treat it much the same. We've got our pi over 4, and we are going to then be subtracting the negative angle measure. And so what is that going to give us? So I'm really adding. I'm adding 1 pi and 9 pi together. That's 10 pi over 4, which does not, even when I simplify that, that's 5 pi over 2. That's not a full rotation. 5 pi over 2 would be to go 90 degrees, 2, this is, each one of these is a pi over 2. So here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. That's not a full rotation. That's more than a full rotation. So this we would say no to. Now let's look and see, what do you guys think about example 22? Would these be coterminal angles? You've got your 3 pi over 2, and you subtract from that your negative 5 pi over 2. Minus a negative means you're actually adding. So what does that give us? 8 pi over 2, which is 4 pi. Now 4 pi, remember with me, well, let me go ahead and think about this by drawing a little picture. 4 pi means that you've gone one rotation. One rotation is 2 pi, right? One rotation is 2 pi. So then 4 pi means that you go 1, 2. So would this, if you're taking those two values, the two values being the 3 pi over 2 and the negative 5 pi over 2, when you take their difference, it actually is a full rotation. It's just that you've rotated 2 times around when you put them together. So this is yes. It's a full double rotation. This is an example of a full double rotation. All right, so now with that, what if instead we ask something different? Let's give 2 angles, one positive and one negative, that are coterminal with the angle here that is provided. One positive, one negative. Think about this with me. Where is 150 degrees? 150 degrees is going to be right over here, getting close to a straight line. So what would be the negative rotation that would end me right there? What would be that negative rotation that would put me right there? Well, just take your 360 and subtract 150 from it. I would need to go negative 210 degrees. But what would also work is if this is 150, what would also work is if I did the following. If I went one, boom, a full rotation and 150. That's to take 360 and add 150 to that. That's going to be putting me at 510 degrees. That would also be coterminal. I would end in the same place. I would have just rotated a lot more, probably gotten dizzy from all of that spinning around and round, right? So there you go, guys. That's an example, 1 negative and 1 positive. How about for example 24, where we're looking at 265 degrees? Well, where is 265? Let's kind of draw our 2 sketches here. We'll do one for positive rotation, one for negative rotation. 265 is just about 3/4 of the way, right? It's going to put me right here. It's almost 3/4, because if you were to go straight down, rotate and go straight down, let me pull it back here. Remember, 270 is rotating from here to there. So if we're saying 265, we're very close to that point. So the negative would be just the difference of 265 and 360. It would be the difference there. So you would take 360, or you could say 265 minus 360, and that gives you that negative 95. That would be your negative 95 degrees. Or you add a full rotation to it, and that'll put you there. So that's to take 265 and add 360 to it. That's going to give you a 625. Whereas for this one, we took 265 and subtracted 360 from it. Again, that's the negative 95. So that's really all it is either adding 360 to it or subtracting 360. So why don't you try 25? But this one is negative. So what would we have? We've got our negative 225, and then we're going to subtract 360 from that. That'll give us a negative value. That'll give us a negative 385 degrees. That's a negative coterminal angle. Or take our degree and add 360 to it. Now we'll have a positive coterminal angle of 335. What about with our radian values? These last few are in radian measure. Same idea. Let's go ahead and first look at taking pi over 12 and subtracting a full rotation from it. Subtracting will give us a negative coterminal angle. When you subtract, you would want to, you can actually kind of take this approach right here. We can take our little fraction, and that is a 1 over 12. And then I'm going to subtract my 2 from that. And let's have our calculator express that as a fraction. Oh man, hold on. Mode, change it to be like this. There we go. So that would be negative 23 pi over 12. Or conversely, if we take pi over 12 and add a full rotation to that, that's going to be grab your calculator, kind of take the same approach. If I have 1/12, but then instead of subtracting the 2 pi, I'm not putting pi in, but just the number values. If I add to that and then express that as a fraction, that's 25 pi over 12. So there you guys go. Why don't you try 27? Find both the positive and the negative coterminal angles. Can you guys try that one? For the negative, we would take and subtract our 2 pi. When you do that, you would have a negative 5 pi over 6 as a coterminal angle with 7 pi over 6. But if you go in a positive rotation and add 2 pi to it, then that's going to put you at 19 pi over 6. This last one is a negative angle, a negative radian angle measure. So same idea. We're going to take and subtract 2 pi. This is going to give us a very large rotation in that negative direction. And that is going to be a negative 47 pi over 18. But if we go in the positive direction and instead take this and add 2 pi to it, that's going to put us at 25 pi over 18. Positive and negative coterminal angles for each of those in both degree and in radian measure. That's it, you guys, for this video. If you had any questions, can you take a moment and share those now. And until next time, stay fired up.